really handy for testing things. There's and or. I won't get into what the double and double or are. It turns out they're more efficient in some cases, but that's the main difference. They're for logicals. So if you have two logical statements, they both have to be true for and to be true. And for or, at least one of them has to be true for or to be true. This is the tilde, and it shows up if you had 401. It shows up in formulas, like in LM. Here's the right assignment and left assignment operator. Ooh, this is a weird one and very dangerous. That's one that does assignment into a namespace or environment that's not necessarily the one we're working in right now. So it's called a global assignment. Here's equal, almost at the bottom, which makes sense because you want everything calculated before you do the assignment, which writes things into a variable. And this is really handy. Question mark and double question mark. Let me show those. Question mark is help. So if you put question mark in any command, like if it's one that is a symbol, you have to put quotes around it. There, describes the variables. There's a help file on that. Most of them have names, so you can go question mark is vector. It'll talk about the command is vector. We'll talk a lot more about the documentation later. Okay. Another one that's handy is if you can't quite remember what the command is, a double question mark searches for a word in all the documentation, and we'll show you every object that has that word mentions documentation. So if I go vector, oh my gosh, I'm in trouble. It gives you everything in any namespace I have loaded now that mentions the word vector. I think that was a bad choice. There's way too many of these. But you know, sometimes it helps you to find something, and then I just click on those to get the help file. Okay, so let's just do a little bit of math. So if we have two variables, x is a variable now. Let's do one called y. That's like 3, 4, 3, 4, 4, the same length. Of course, we can do all sorts of math on it. So z equals, remember, math applied to things is applied to every item in it. So I can square everything in x and add it to everything in y. Okay, there's the vector that comes out of that. I'll show you a few mathematical. Oh, before I say that, I'm going to show you another thing that happens. So square it. Now this looks like it shouldn't work because 5 is just a single number instead of 1, 2, 3, 4, 5 numbers. So how can I square all of these and then add a vector to it when I just added 5? This could be dangerous, but R does something called recycling, which means if it has a vector of 5 things here and you try adding something that's not a vector of 5 things, it'll replicate this till it matches a vector of 5 things. So in essence, it's going to do what you hope it would do and add 5 to every one of these. Let's look. By the way, I don't need to even save it. I could just do this if I wanted to. There we go. Just immediately square everything in x and add 5 to all of them. Why recycling can be dangerous is watch this little trick. Okay, x squared. This has 5 items in it. What if I add this vector, 1, 2? Now you're going to go, wait a second, this has 5 things in it, this only has 2. Well, recycling will expand this into 1, 2, 1, 2, 1, and add it in. It's also going to tell you that you shouldn't have done that. But it runs it anyway. So be a little careful. This is sometimes a feature if you want to add a repeating pattern to something, but it will allow you, with a warning, to add vectors that aren't the same size by expanding the one that's a smaller size. Okay. I'll just show you a fast group of math functions. More math functions that can go in. So let's say one that's handy for x is you've got minimums. Oh, I'll just do min. You have minimums. You get the maximum of y, mean of y. There are so many functions. Standard deviation, of x. Variance of x. Median of x. Sum of all the things in x. So these are all really handy commands. Let's see. What am I missing? Many objects will have a summary written. So if you say summary, for instance, a vector, it'll essentially do the minimum, maximum, first and third quartile, mean, and median. So essentially summarize it. Okay, so to finish up, I'll just show another mathematical combination. So let's say, what are my variables I have floating around here? I've created a few, like ZZ, there's one, ZZZ. Here's something interesting. So I can take the sine. There's lots of mathematical functions built in. There's some special named variables, variable values. Now notice I can add numbers in. Okay, that'd be boring to add 5 numbers. But there's some special ones. There's NA, which you can all substitute. That is the missing value. So if you have a missing value in a data set, notice it takes the 5 things here, adds them to these 5. Something added to missing ends up being missing. Another one like that is, there's also a not a number, which is a weird one. I'll show you where not a number comes from. Not a number comes from computations where the value is undefined. So 0 divided by 0 gives a not a number in there. So for instance, if I take a vector that's 0, 1, 2, 3, and divide it by the vector 1, 2, 1, 2, oh, no, 0, 1. It's going to take each of these things and divide them by each one of these. You'll notice the 0 divided by 0 gave not a number. Another value that can be put in are a plus and minus infinity. So how would you get that? Well, let's see, 0, 1, 2, 3 divided by C 0, 0, 0. Notice 0 divided by 0 ends up being not a number, but 1 divided by 0 is infinite, positive infinity, 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 infinity. So those all are values that are possible. The NA, which is specifically for missing data, you don't know the value. Not a number, which is a result of a computation where you can't get a value. And then you have infinity. Okay, I think that's it. If you sit and do calculations, you can use all sorts of functions. And I think I will stop right now. Bye.